Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Ibrahim bin Mana. Is our group, which is Muhammad Amirul Hafiz bin Muhammad Aminuddin, and the last one is Abdul Jamil Shawwal bin Abu Miri. So for our group, we want to present about our project, which is IoT planting watering system. So for our introduction, our project using IoT watering system. Next, the condition of plant watering through the smartphone, value of humidity, moisture, and temperature that measure, then display. And the last one is watering system controlled through the smartphone. So for our problem statement, the traditional irrigation system do not include the watering saving features. So the plant under a lot of stress and impair their load because of the uneven soil moisture level. So the issue is worsening when lack of automatic control, which lead to ineffective water management, thus resulting on the fertility of plant.
Okay, so next I will continue the presentation. So this is our objective for the project. First one is to design a controllable and monitored watering system by using an IoT system. And the second one is to develop smart plant monitoring system with a suitable model for the new era in agriculture. And the last one is to develop high distance controller to watering a plants. Okay, so this is a material and the component that we use in this project. We have six of the component, which is the first one is ESP8266 Wi-Fi module that function to transmitting and receiving signal. And the second one is soil moisture sensor to detecting and measuring the soil moisture. And the third one is humidity sensor is to detecting and measuring water vapor. And the fourth one is DC water pump function to pump water to sprinkler. And the fifth is a relay to control on off the operational of DC water pump. And the lastly is battery to additional power supply to the system. Okay, and then for the flowchart, we have a two-ways progression, which is the first one is humidity temperature surrounding measured, and then the second ways is to soil moisture surrounding measured in the soil. Okay, and in this first way, humidity value and the temperature value will display on the phone, and then it will proceed to the terminator. So for the next step to is soil moisture, and it's same like humidity and temperature. It will display on the phone, and then if the reading higher than 70, which is we must watering the plant. And if after the plant is watering, so the reading can be below than 70, and the process will be the end. All right.
So I will be continuing on the next part. So firstly is about the circuit connections. So basically based on all the components that stated previously, this is how all those components are connected to. However, based on this picture, there are several components that will be removed due to several factors and problems, which is PIR motion, motor on off button, and the LCD display. And for the DHT11 will be changed to DHT22. So, as we said before, we'll be monitoring the progress of the plant by using GUI sketch that is displayed as this one, where we use the blink application. So as you can see here, we have two gauge indicating the display value of the humidity and the temperature that is measured by our DHT22. And then the value of the soil moisture sensor will be displayed in terms of graph here, as you can see the graph, and the value can be monitored at a live 1 hour, 6 hour, 1 days, 1 week, 1 month, or even up to 1 years. And then the last part is that we have the button to turn on and turn off the water pump. based on our own decision. If the value of the moisture is too high, then we can supply the water by turn on the button for supplying the water to the plants. And then the last part, which is the coding. So for the coding part, here is 3 header file that will be used along all this coding that written below. And then we set the character author, SSID, and the pass. Here is the coding for where we connect our project with our Blink application, and then the Wi-Fi name that will be used and the password. And then here we define everything pins that will be used for every component that connected to it, including the LED pin 1, LED pin 2, indicator of the motor, and then we have the pump relay, soil moisture, and then the DHT22 sensor. And then we start the blink, and then we set the initial pump state, the water pump to 0, it will be not turning on. Then we set the void DHT data to send the value of the temperature and the humidity to our blink application. And then the void soil moisture data will be sending the value that detected by our soil moisture sensor to our blink application to will be displayed on the graph part. And then we set the blink right V node, which is this is the functioning of the button. If the button set to 0, which is turned off, then our relay for our water pump will set the water pump to 0, not functioning, and then the LED red will be turning on. And if we put the button to 1, which is turned on, then our water pump will be turned on and flowing the water, and our LED green will be turning on. And then the void setup, where we set everything including the relay, the LED 1 and LED 2 as our output for the project. And then we start the blink to run. So here is all the components we have connected. So we have the ESP8266, we have the relay module, we have the soil moisture sensor, and then the DC motor water pump, and also the DHT22. So this is the interface. So for the current situation, the soil moisture value is below than 70, around 46 value. So this is the graph. So actually you can monitor at the 1 hour, 6 hour, 1 day. So you can monitor the value. So here I set the live value. So at current condition, due to the moisture of the value of the moisture is lower, means that there is consist of water here, so that the water pump will not be turning on. We will not set the water pump to turn on, and the LED will be turned on for the red one. However, if we remove the soil moisture, okay, if we remove the soil moisture from the water, means there is no water, then the value will start increase on the monitor. The value here that is around 88. So here we can set the conditions of, we can turn on the water pump to flow. So we just turn on, then the water will flow. If the value of the soil moisture already indicating here lower than 70, then we can turn off the water pump. Here you need to know that when we turn on the water pump here, the green LED will be turned on instead of red. Here, if we turn on, turn off, this is here, red, turn on. If we turn on the water pump, then the green LED will be turning on. So that ends.